Imagine you're floating in the vast emptiness of space, far beyond any galaxy, beyond even the largest clusters of galaxies, in a region so remote that light from the nearest star may never reach you. You turn your gaze in all directions, expecting to see at least a faint glow in the distance, but instead you find nothing, just an endless sea of darkness stretching infinitely. It feels like true emptiness. But what if I told you that hidden within this darkness is the largest structure in the universe, an enormous intricate network that binds together every galaxy, every cluster, and every cosmic entity? This is the cosmic web, the unseen skeleton of the universe, and today we're diving deep into its mysteries. For much of human history, our understanding of the cosmos was limited. Ancient astronomers looked up at the night sky and saw a scattered array of stars, planets, and a glowing band of light, the Milky Way. As telescopes improved, we discovered that the Milky Way wasn't the entirety of the universe, but just one galaxy among billions. For a long time, scientists believed galaxies were spread randomly across space, drifting independently with no overarching structure. But as technology advanced, something unexpected was revealed. In the 1980s and 90s, astronomers conducted massive sky surveys, mapping the positions of galaxies on an unprecedented scale. The results were shocking. Galaxies weren't randomly scattered at all. Instead, they were arranged in vast interconnected filaments, forming a massive web-like structure spanning billions of light years. And in between these filaments, enormous voids, cosmic deserts where almost nothing exists. This immense structure, now known as the cosmic web, is the largest known pattern in the universe, stretching across the cosmos in an intricate network of filaments, walls, and voids. But where did this pattern come from? To understand, we have to go all the way back to the very birth of the universe, the Big Bang and the birth of structure. Around 13.8 billion years ago, the universe was born in a violent explosion, the Big Bang. In its earliest moments, everything was unimaginably hot, dense, and chaotic, a swirling plasma of energy and particles. But even in this early chaos, there were tiny variations, slight differences in density, some regions being just a fraction denser than others. These subtle differences may seem insignificant, but they would determine the very structure of the cosmos. As the universe expanded and cooled, these denser regions exerted a stronger gravitational pull, slowly attracting more and more matter. Over millions and billions of years, these areas formed long thread-like filaments, regions where galaxies and galaxy clusters would eventually form. Meanwhile, the less dense regions were pulled apart, creating vast, empty spaces, the cosmic voids. This process, driven by the invisible hand of dark matter, gave rise to the web-like structure we see today. But what exactly is holding this vast structure together? The answer lies in an invisible force that has puzzled scientists for decades. Dark matter. Dark matter, the invisible glue. We often think of the universe as being made of ordinary matter, atoms, stars, planets, and galaxies. But in reality, this visible matter makes up just 5% of the cosmos. The vast majority of the universe, around 85% of its mass, is composed of something we can't see, dark matter. Unlike normal matter, dark matter doesn't emit, absorb, or reflect light, making it completely invisible. But despite its ghostly nature, its gravitational pull is undeniable. Dark matter forms the backbone of the cosmic web, acting like an invisible glue that holds everything together. Without it, galaxies and galaxy clusters wouldn't have enough gravity to stay bound. They would simply drift apart. Scientists have mapped out dark matter's influence by studying how its gravity bends light from distant galaxies, a phenomenon known as gravitational lensing. The results are astonishing. Dark matter appears to form vast filaments stretching across space, aligning almost perfectly with the cosmic web itself. But if we can't see dark matter, how do we truly know the cosmic web exists? The answer lies in supercomputer simulations and powerful telescopes. Seeing the invisible, mapping the cosmic web. Since the cosmic web isn't made of glowing stars or hot gas, we can't simply point a telescope at the sky and see it. Instead, Astronomers use indirect methods to reveal its structure. Large-scale galaxy surveys like the Sloan Digital Sky Survey, SDSS, have mapped the positions of millions of galaxies, allowing scientists to trace out the filaments they form. But even more fascinating are the cosmic simulations, vast digital models that recreate the evolution of the universe inside a supercomputer. By inputting the laws of physics and the known properties of dark matter and normal matter, scientists have created detailed simulations of the cosmic web's formation. These simulations show something incredible. The structure of the cosmic web looks eerily similar to the neural networks in our own brains. Both systems are made of interconnected filaments, with nodes where connections are strongest. Could it be that the universe itself follows principles of self-organization, much like biological systems? Some scientists have even speculated that the cosmic web might hold deeper secrets, perhaps even hints about the fundamental nature of reality itself. But this is just the beginning. How do these massive cosmic threads influence galaxies and star formation? What secrets are hidden in the dark voids between them? And could the cosmic web be the key to understanding dark energy, the mysterious force driving the universe's expansion? To uncover these mysteries, we need to go even deeper. Now that we understand how the cosmic web formed and the invisible forces that shape it, let's take a closer look at its components, its filaments, nodes, and voids, and how they dictate the very structure of the universe. Imagine a spider's web stretching across an entire continent, with strands so thin they seem invisible, yet strong enough to hold entire cities together. That's what the cosmic web is like, but on a scale that defies comprehension. It is a network of interwoven filaments, each spanning hundreds of millions of light-years, made of galaxies, gas, and dark matter. These filaments connect at dense intersections, or nodes, where galaxy clusters and superclusters form. But what's even more mysterious are the dark, empty regions in between, the voids, vast stretches of nothingness spanning even larger distances. To get a sense of this structure, let's start with the filaments. These are the veins of the universe where most of the matter is concentrated. Each filament is like a superhighway of galaxies, stretching across space, feeding galaxy clusters with fresh material and shaping the evolution of entire cosmic regions. Scientists estimate that about 60% of all normal matter in the universe is locked within these filaments, an astonishing realization that reinforces the idea that galaxies are not isolated, but rather deeply interconnected by this cosmic infrastructure. But what's driving the movement of galaxies along these filaments? The answer lies in gravity and the flow of cosmic matter. Think of it like rivers forming in a landscape. Matter naturally follows the path of least resistance, flowing along the gravitational wells created by dark matter. Over billions of years, this movement has shaped the cosmic web into the vast interconnected structure we observe today. At the crossroads of these filaments are the nodes, colossal intersections of galaxies and dark matter, forming the densest and most gravitationally bound regions in the universe. These nodes are where galaxy clusters and superclusters emerge. The Sloan Great Wall, one of the largest cosmic structures ever discovered, is a perfect example. It spans over 1.3 billion light-years and contains thousands of galaxies, all bound together at the intersection of multiple filaments. These nodes act as cosmic anchor points, regulating the structure of the web itself. But while the filaments and nodes contain the majority of the universe's mass, the voids are equally fascinating. These cosmic voids are vast empty spaces spanning up to 500 million light-years across, containing barely a trace of galaxies or matter. The Bootes void, one of the largest ever discovered, is so empty that if you were placed in its center, you wouldn't see another galaxy for hundreds of millions of light-years in any direction. These voids make up nearly 80% of the observable universe, yet they remain some of the least understood regions in cosmology. But here's the mystery. Why are voids so empty? The answer lies in the gravitational dance of the universe. As galaxies and matter accumulate in filaments, the less dense regions are left behind, expanding into vast emptiness. Over time, These voids grow larger as gravity continues to pull material into the surrounding filaments, leaving behind true cosmic wastelands. Yet, voids are not entirely devoid of mystery. Some theories suggest that these vast emptinesses may hold clues about the nature of dark energy, the enigmatic force driving the accelerated expansion of the universe. Could it be that dark energy is somehow linked to these voids, playing a role in their expansion? Some researchers believe that by studying voids, we might unlock new physics that could change our understanding of the cosmos itself. But there's something even more profound to consider. The cosmic web doesn't just shape galaxies, it dictates their very fate. Where a galaxy forms within the cosmic web can determine its size, shape, and even its chances of survival. Galaxies. In dense filaments experience frequent collisions and mergers, rapidly evolving over time. Meanwhile, galaxies in voids remain largely isolated, evolving much more slowly. This means that the cosmic web is more than just a structure. It is a cosmic blueprint, an unseen hand guiding the evolution of everything in the universe. But what happens when this web stretches and shifts over billions of years? Is the cosmic web static, or is it evolving? And could it hold the answer to one of the biggest mysteries in cosmology? What lies beyond the observable universe? To uncover these answers, we need to go even deeper. We now know that the cosmic web is an immense, ever-connected network of filaments, nodes, and voids, a structure that shapes the very nature of galaxies and their evolution. But what if I told you that this web is not static, that it is alive, in its own way, shifting, stretching, and changing over billions of years? The cosmic web is a dynamic structure, constantly evolving under the influence of gravity, dark matter, and a force that remains one of the greatest mysteries in physics, dark energy. To understand this evolution, let's rewind the cosmic clock and examine how this web has changed over time. The past, a universe in formation in. The early universe, just a few 100 million years after the Big Bang, the cosmic web was barely recognizable. At this time, there were no well-defined filaments, no massive galaxy clusters, just an ocean of gas and dark matter beginning to take shape. These were the universe's so-called dark ages, a period before the first stars ignited. But, even then, the seeds of the cosmic web had already been planted. As the universe expanded, regions of slightly higher density began pulling in more and more material due to gravity. Over time, this uneven distribution of matter grew more pronounced, with dense regions forming into thin, elongated structures, proto-filaments of what would eventually become the cosmic web. Simulations of this process, like the Illustries and Millennium simulations, show that these filaments began as faint tendrils, but as time passed they thickened and strengthened, drawing galaxies into their gravitational grasp. About 1 billion years after the Big Bang, these filaments became populated, with the first galaxies, fed by streams of cold gas funneled along the web's structure. This gas acted as the raw material for star formation, giving birth to the first great cosmic structures, massive star-bursting galaxies that would later merge and evolve into the grand spiral and elliptical galaxies we see today. At this point, the universe was much smaller, and the cosmic web was tightly packed, its filaments drawn together under the influence of gravity. Galaxy clusters were closer, mergers were more frequent, and the universe was a chaotic, violent place with galaxies constantly colliding and reshaping. But then, something began to change. The present, a battle between gravity and dark energy fast forward. To today, nearly 13.8 billion years after the Big Bang, and the cosmic web looks vastly different. The filaments have stretched and expanded, the voids have widened, and the distances between galaxy clusters have grown immense. This change is driven by two opposing forces, gravity and dark energy. Gravity, powered by dark matter, is the builder of the cosmic web, constantly pulling galaxies together, strengthening filaments, and thickening the nodes where galaxy clusters reside. But dark energy is the destroyer, a mysterious force that accelerates the expansion of the universe, stretching filaments apart, making voids larger, and slowing down the formation of new galaxies. The evidence of dark energy's influence can be seen in the accelerating expansion of the universe. a phenomenon first discovered in the late 1990s through observations of distant supernovae. Scientists found that rather than slowing down as gravity would predict, the universe's expansion was speeding up. This revelation suggested that dark energy, a force more powerful than anything we had previously considered, was tearing the universe apart. But here's where things get even more fascinating. This expansion is not uniform. While dark energy is stretching the cosmic web on the largest scales, gravity is still dominant on smaller scales, keeping galaxy clusters bound together and allowing filaments to persist. This means that even though the universe is expanding, the structure of the cosmic web still plays a crucial role in shaping galaxies, forming new stars and directing the movement of matter. This balance between dark energy and gravity determines the fate of the universe. But what happens next? The future. Will the cosmic web disappear? If dark energy continues accelerating the expansion of the universe, what will happen to the cosmic web in the far future? The answer depends on how dark energy behaves over time. One possibility is that the filaments will continue stretching, becoming thinner and more fragile, while voids grow ever larger. In this scenario, billions of years from now, galaxies will drift farther apart, their interactions becoming rarer. The cosmic web will still exist, but it will be stretched to such an extent that its filaments will become faint, nearly invisible, and the universe will appear more and more empty. Another, more extreme possibility is something scientists call the Big Rip. In this scenario, dark energy's influence keeps growing stronger, eventually overcoming even gravity itself. If this happens, not only will galaxy clusters be torn apart, but even individual galaxies, stars, and eventually atoms themselves could be ripped apart by the relentless expansion of space. In this version of the future, the cosmic web would completely unravel, and the universe as we know it would cease to exist. But there's a third possibility, one that suggests the cosmic web could continue to evolve indefinitely. Some models predict that dark energy might not be constant, but rather change over time. If dark energy weakens in the distant future, gravity might once again take control, leading to a universe where filaments remain intact, where galaxies continue to form along cosmic highways, and where the web itself becomes eternal. Regardless of which future awaits us, one thing is certain. The cosmic web is not just a background structure, it is the very foundation of everything we see in the universe. It dictates where galaxies form, how they evolve, and even how the universe might end. We've journeyed through the cosmic web's origins, its filaments, nodes, and voids, and how it has evolved over time. We've explored the battle between gravity and dark energy, the fate of the universe, and the possibilities of a future where the cosmic web either stretches indefinitely or collapses upon itself. But before we conclude, let's take one final leap into the unknown. What if the cosmic web is more than just the structure of our universe? What if it holds the key to something even greater, something that challenges the very nature of reality itself? Imagine for a moment that the cosmic web is not just a vast network of galaxies, but a pattern, one that extends beyond our observable universe, possibly connecting to other universes beyond our reach. Scientists have long speculated that our universe might not be the only one, and that there could be countless others forming what is known as the multiverse. If that is the case, could it be that the cosmic web is merely a fragment of a much grander structure linking universes together like the filaments link galaxies? Some physicists theorize that our universe's cosmic web could be part of a larger, multidimensional framework, one where different universes exist in vast cosmic landscapes, separated by regions we cannot yet perceive. This idea is supported by certain interpretations of string theory, which suggest that our universe might be just one brain within a higher dimensional reality. If this is true, then the very fabric of the cosmic web might not only reveal the structure of our universe, but also hint at the existence of unseen realms. And here's where things get even more intriguing. There is a striking resemblance between the cosmic web and something much closer to home, the structure of the human brain. When scientists compared simulations of the cosmic web with neural networks in the brain, they found an eerie similarity. Both are composed of vast, interconnected networks of filaments with nodes acting as central hubs. Some researchers have even suggested that the universe itself might function like a massive cosmic brain, where galaxies exchange information in ways we do not yet understand. Could it be that the universe is not just a collection of galaxies, but something more, a living, thinking entity on a scale we cannot yet comprehend? But perhaps the most mind-bending possibility is that the cosmic web might be a holographic projection. According to the holographic principle, proposed by theoretical physicists like Juan Maldacena, all the information in our three-dimensional universe could actually be encoded on a distant two-dimensional surface. If this theory is correct, then the cosmic web, this vast network of filaments and voids, might not be what it seems. Instead, it could be a projection of a deeper reality, one where the true nature of existence is yet to be uncovered. Regardless of which of these theories proves to be true, one thing is certain. The cosmic web is not just a passive structure. It is the skeleton of the universe, the unseen framework that has shaped everything we know. It tells us where galaxies form, how they move, and even hints at the fate of the cosmos itself. The more we study it, the more we realize that we are not isolated beings floating in space. We are part of something far greater, woven into the very fabric of the cosmos itself. And now we are left with one final question. What else is out there? Could there be structures beyond the cosmic web, hidden dimensions waiting to be uncovered? Could the voids between filaments contain secrets about the nature of dark energy and the fate of the universe? Or could the cosmic web itself be a clue, a sign that our universe is part of something even bigger, something just beyond our reach? Only time and future discoveries will tell. If you enjoyed this journey through the cosmic web, don't forget to like this video, share it with fellow space enthusiasts, and subscribe to the channel for more mind-expanding content. And tell us in the comments, what do you think the cosmic web could be hiding? Until next time, keep looking up, because the universe is always speaking to us, whispering its secrets across the cosmic highways of time and space.